Or two, let's get to the point with the ready, the zeros of each polynomial function. You set each of these factors equal to 0 and solve for x. I will note that the only things I'm going to be talking about here for these answers are going to be the real numbers rendition. So this is going to pretty much exclude me from having to write any roots that are imaginary, because all of unit 4 is just going to focus in on real numbers, normal xy planes like this, nothing with I terms involved. Okay, sound good? So what are the zeros? The opposite of this positive 4 is going to be negative 4. Opposite of negative 2 is positive 2. Opposite of 7 es, yeah, positive 7. Okay, capiche? So you'll do that here. You'll have 3 numbers that you get there. And then here, if you try to solve this, you're going to get that x is eventually plus or minus 5i. But in this case, depending on who you ask, you just say that it's an empty set for those zeros because they're imaginary. So I'll leave that up to you on what you think it would be. So that's 1 and 4. So 5 and 8 are going to feel very similar because now it's just asking what's the domain. And we saw in 4.2 that we really don't want to have our denominator go to 0 because that's undefined. And that means that we have a line that goes way down, but then way up as it approaches where x is 0. And this is conflicting because they're saying 2 different things. It's like saying, oh, I'm going up the stairs and I'm also going down the stairs. Figure it out. You know what I mean? So when we talk about this domain, it's going to look very similar to what you saw in problem 1. But now I'm going to say that my domain is all real numbers with the exception of x not equaling negative 4, 2, or 7. So this is saying that I want to use all real numbers, anything that's positive or negative, and even 0, but I don't want to use negative 4, 2, or 7, respectively. Capiche? Do you see how that's different than just saying what the zeros are? Now that we're talking rational functions here. Okay, so for 6, you'll say that in a similar context, you have your domain of all real numbers, but x shouldn't equal, or you should be excluding 3, because 6 divided by 2 is 3, 1/8, and 5. You know what I mean? Does that make sense? Shouldn't be too tough. Okay, for the set, we're sketching these respectively. I'm going to list out some steps that I use to talk about this. And it's really going to be, what are these asymptotes going to have to be? I see that we have a division of just x, so there's no vertical shift or horizontal shift. So since there's a left or right, like you're not going anywhere, so left, right, 0, up, down of 0. You do have this vertical stretch factor of 2. Sorry, it's like 4. So what can you say here? You're not going anywhere, so your vertical asymptote is still where x equals 0. Your horizontal asymptote is still where y equals 0. So as a quick sketch, I'm going to do my best to color coordinate on this, so give me a second to do that. All right, so I color coordinated. I also numbered them so you can see what lines I'm talking about. Yeah, that makes sense. So I have this vertical asymptote when x is 0, and this makes sense because if you have 4 over 0, that's undefined. So we want to avoid that at all costs. We also want to avoid where y equals 0 with our horizontal asymptote, because there's no way we can get this function to equal 0. That would only happen if we were working with the numerator, but it's consistently 4, so that's not happening. We can talk with domain. We want to talk about all the negative values up to where x equals 0. So from -infinity to 0, we use a union, and then continue from 0 to infinity. And believe it or not, our range is the same thing because we're doing all these negative numbers up to 0. And then we continue upwards for all the positive numbers. Again, the range is dealing with y values, domain is with x values. So this isn't always going to be the same song and dance of like the same numbers that it excludes. This is just a by chance type of problem. Okay, so we did that. And now we're going to check some points. So I think the easiest points to check on, since our vertical stretch factor is 4, would be numbers like the following. I would definitely check 1. I would check -1. I would also check 4. And I would also check -4. So 4 over 1 is just 4. So that means when x is 1, you have an outcome of 4. When x is -1, that outcome is -4. So -1, -4. When you have x is 4, 4 over 4 is just 1. And this means the outcome there is going to have to be -1. Okay, so quick graph of that. Show arrows that go up towards our asymptote, vertical one, and do your best to show that this has like a little bit of a curve to it. I guess some other points you could throw in as well, just because when x is 2, the outcome is 2. And when x is -2, the outcome is -2, respectively. So I was a little short on this point, but there we go. Now I'm hitting it. You know what I mean? Okay. Take a moment to pause and make sure that this all makes sense before we talk about the next one. So I started to fill in a little bit more than I wanted to, but oh well. You have a vertical asymptote when x is 0, because x could be equal to 0, but that's undefined. So that's why I'm drawing this here. Again, same spot as the previous problem. This is just by a coincidence. You also have this horizontal asymptote when y equals 2, because you're taking everything and shifting it up 2 units. So it makes sense that that's there. Domain is excluding 0. The range is excluding when y equals 2. And so let's get some points. Some points of convenience, I'm going to say, are usually dictated off of your stretch factor, which in this case is 3. So I'm going to keep it pretty simple. Use points like 1, -1. I'll use 3, -3. And I'll also throw in some, can I pull a 9er? Yeah, I'll throw in 9, -9. All right. So when x is 1, that outcome is 3 plus 2, which is 5. It's 1, 5. When x is -1, you have -3 plus 2, which is -1. So -1, -1. When x is 3, that's going to be 1 plus 2. So that outcome is just 3. And then this is going to be 3 divided by -3. Sometimes I should sketch out the work. So this is checking where x is -3. And if you add on 2 to that, it's -1 plus 2, which is just 1. So 3, 3. -3, 1. And as requested by myself, when x is 9, you have 2 and you're adding on a third. And then otherwise, it's 2 minus a third. So that's 5/3. So a little tough to graph these out, but nothing we can't handle. -9's pretty far out, I think. I don't know if it's going to be on here, but it makes sense that it's a little bit more than 1. So, boom. Are you not entertained? This is what the graph would look like. Boom. Okay, capiche, makes sense. Pause the video, make sure it makes sense, and we'll continue onwards. I think I'm going to do a few of these problems in this video. All right, so let me preface this with a few thoughts I have. This denominator can't equal 0, and this means that you have an asymptote when x is positive 3, which is the opposite of this 3. You don't have a vertical shift, so your asymptote on the horizontal respect is y equals 0, so you don't shift it up at all. Your domain excludes when x is 3. Your range excludes when y is 0, but it's still all real numbers for those respectively. So I'm going to assess now this 5 and this negative idea. So at a quick glance, this being negative shows me that you're going to have your graph ending up in the top left and the bottom right. Reason being is that it's negative. It's going to be the opposite of 1 over x, which is normally quadrant 1 and quadrant 3. So just at a quick glance, I know that. I could get crafty and just try to go like that and like this, moving over 1 down 5 from where our new origin is, and even going over 5 down 1. I actually want you to try this and double check. Do these points work? If I plug in when x is 2, does that produce an outcome of 5? Try that for me real quick. Hopefully you say it works, which again is me like, I don't know if it's me being lazy or I just noticed this pattern, but like you're having respective slopes of like over 5 down 1 or over 1 up 5, respectively, kind of working in that realm of like it's a negative slope and it's a version of 5 over 1 or 1 over 5. So that's how I'm going to approach these. So what other points do we have? You have negative 2 and 1. You could also do 4, negative 5. Again, if you're not convinced that these work, please try them out. I'm pretty confident that they work though. And then also 8, negative 1. Okay, capiche, makes sense. I'll throw in a fraction in there too. When x is 1, you end up with negative 5 over 1 minus 3, which is negative 2. So 5 halves. So when x is 1, the outcome's 2.5. And that's probably going to be something similar to this. So there you go. My predictions were right. Again, if you don't trust the arithmetic, plug in respectively. But I think that this is like a really cool example. And yeah, kind of showcases a little bit of like the craftiness you can get of like, if you know that your stretch factor is 5, chances are you can move in increments of 5 and 1, like slope style away from the origin that's new. So I challenge you to try that. I'll give you a moment to try 12, get your hands dirty there. Hopefully you trust me on all this work. We've shifted to the left 5 units, which shows that our domain can equal negative 5. We've shifted down 4 units. So that should show that y can equal negative 4. These are a slew of points that work. Luckily, our stretch factor was only 1, so it's pretty easy to see that conversion of like over 1, up 1 from the origin, and then you deal with some halves. So notice those are in there. Yeah, hope that one works for you. The go concludes with, given the root, figure out the other roots and also the factors that are there respectively. I'm going to approach this in a few different ways, so just be mindful of that as you see me work through this. I know that if I have a root, and recall this is a thing, if you plug in the root, and this is just a remainder theorem really, but if you plug in the root, you get your remainder. But remember, from synthetic division, you can also use that to build up what the other factor set's going to be. So let's try this. When x is 1, and we use our coefficients of this 1, this negative 3, negative 61, and 63. If we run this gambit, drop 1 like it's hot, 1 times 1 is 1, negative 3 plus 1 is negative 2, 1 times negative 2 is negative 2, this is negative 63, and then minus 63 gets you to 0. Cool. So this means that another way we could write this is x minus 1 and then x squared minus 2x minus 63. And so let me ask you, can this be factored further? Are there factors of negative 63 that add up to negative 2? There's negative 9 and 7. That works. So then this could be rewritten even further. It's x minus 1 times x minus 9 times x plus 7, giving us our roots respectively as these opposites: positive 1, positive 9, negative 7. So here you are. And this isn't to say that synthetic division is going to be the only way that you approach these. Like, I think that in this problem here for 18, your best bet is to do factor by grouping instead of plugging in this as your root, you know? Your best bet here, I guess this is one I'll do. You could plug in when x is 0, but it's just going to kick you back just, I think, nothing. So you're better off factoring out what's common, like 6x, and then factoring that out respectively from everything. And then what's that, minus 10? And then this can be rewritten to 6x times x minus 5 times x plus 2. This is the most factored form. And you know that all of your roots are going to be opposites of these numbers. So your roots are respectively 0, 5, and negative 2. There you go, 3 roots. And it makes sense because it's degree 3. You know what I mean? Maybe I'll do one more. This video is rather long. Hope you don't mind. I'll go for this one. If you have a root of 8 and you have this large polynomial that I don't think can be factored super well, you can use synthetic to figure out what the rest should be. You could use polynomial long division, but more room for error on that. That's why I avoid it personally. This is definitely 8. Okay, so negative 48, right? So that's 9. This is 72. 0. All right, so you get x squared minus 6x plus 9. So this is one of the factors. And remember, you also have x minus 8. And then can this be factored further? Factors of 9 that add up to negative 6? Sure can. X minus 3, x minus 3. With some multiplicity there, so I won't forget that. So our roots here are still consisting of 8 and also 3. Side note, this has multiplicity of 2. Some would call it a double root or a dub. So there you go. Boom. Hope that this video was helpful. If you were stuck on anything, let me know. Again, your final answer bits were these. Thanks for watching. Take care. Brush your hair.